Hello, I'm Duncan Penizzato, a field engineer here at One Energy, and today we're going to talk about something called buoyancy. If you've ever gone to the pool and lounged around in the water on a floatie or a pool noodle, you can float around all day like that, right? That's because of buoyancy. What is this buoyancy and how does it affect objects? Well, when an object is placed in a fluid, it pushes some water out of the way to make room. However, that fluid does not like being forced out of its spot and it pushes back against the object. The force that occurs from the fluid pushing back against the bottom of the object is the buoyant force. Put simply, buoyancy is a force just like gravity or lift, but unlike gravity, which is a downward force, buoyancy is an upward force. The amount of force exerted on the object can be found using Archimedes' principle. The buoyant force is equal to the density of a fluid times the gravitational constant and the volume of displaced fluid when an object is put into it. The volume of displaced fluid is the amount of fluid that is pushed away when the object was added. Think about a really full glass of water. If you start to add ice cubes to it, the water overflows. That's because those ice cubes took up space that the water previously occupied. If we catch all this overflow in another container, we can measure the volume of the overflow, which is called the volume of the displaced fluid. Believe it or not, every object in a fluid, regardless of its weight, has a buoyant force acting upon it. From the equation of Archimedes' principle, we can see that the buoyant force that an object experiences does not depend on the weight of the object, but more so on 1, the volume of displaced fluid when an object is placed in fluid, and 2, the density of the fluid itself. Gravity, on the other hand, is actually the force that depends on the weight of the object. If the buoyant force is larger than the force of gravity trying to pull the object down, then the object will float. But if the force of gravity is larger than the buoyant force, then the object will sink. Simply put, buoyancy is the force that causes an object to float. Let's conduct an experiment to explore this concept a little more. Here we've got a tub of water and a plastic floatie. The water is the fluid that we're going to put the toy floatie into. And without doing much to the toy floatie other than putting it in the water, the floatie will float because the buoyant force is bigger than the force of gravity that is acting on the floatie. But if we start to add some weight to the floatie, you can see the floatie starts to sink a little. Adding these coins into the floatie increases the floatie's weight, which means we're increasing the force of gravity acting upon the floatie. So we're slowly increasing the force of gravity by adding these coins, but our buoyant force isn't changing much at all at this point. If we add enough coins, however, we will reach a point where the force of gravity is larger than the buoyant force, and when that happens, our floatie sinks. Buoyancy is all around us. Floaties and pool noodles are buoyant in the swimming pool, just like this ice cream is buoyant in the root beer float. They don't call it a root beer float for nothing. Thanks for watching this installment of Science Shorts. Be sure to subscribe to our YouTube channel to catch the next episode. And remember, challenge everything.